Dear ladies and gentlemen, my colleagues Gerald Hofmacher, Tobias Kein, Benjamin Zierninger and I, Anton Hössl, would now like to present you our diploma thesis called Heartbeat. Our aim was to Our aim was to develop an ECG the size of a credit card.
As you can see on the picture, we are a rather big team. This is due to the fact that our project deals with a complex medical topic. Furthermore, it was very challenging to coordinate all software and hardware components because all elements were built on our own. Our team consists of 14 students who are organized in 3 subgroups. Moreover, we have been supported by 2 teachers of our school. Mr. Zorner has helped us regarding technical concerns, while Ms. Handel-Gruber has given us linguistic advices.
As you can see in the shown diagram, cardiovascular diseases are the most common causes of death in Austria as well as in other developed countries. Because we were very shocked by this high feature, we developed a small and cheap ECG to help to reduce cases of death that are caused by cardiovascular diseases. Furthermore, our ECG should also be flexible. On the one hand, we want to provide a ECG for the professional usage, especially for ambulance vehicles, because commercial ECGs are quite expensive. Therefore, only a few ambulance vehicles are equipped with ECGs. Due to our ECG, it is possible to equip much more ambulance vehicles than now. On the other hand, we want to provide an ECG for the home sector. For example, for athletes or bedridden people. Another aspect that motivated us to carry out this project was that blood pressure monitors are available in almost each household in Austria. Therefore, we asked ourselves, why don't we try to make ECGs available in each household in Austria?
Since many people don't know how an ECG works or even what an ECG is, I want to give you now a short overview. With each beat, the heart produces a typical current voltage characteristic, which can be measured and interpreted. Those measurements are performed by a hardware which will be explained later on. The most basic diagnostic analyses are the frequency the heart is beating with and the regularity of the heartbeats. Both diagnoses can be made by using software or by an amateur. Of course, further diagnostic analyses can be made, but those lie within the competence of a medical expert.
In this feature, you can see all components of our project. The electrons attached on a human body are connected via the ECG cable with the ECG hardware. The ECG hardware measures the voltage differences between the single electrodes. The measured values are sent wireless via Bluetooth to a mobile device. The smartphone or tablet converts the received information to screen information and displays the heart curve on its screen.
Before I start explaining how our ECG works, I want you to know that we have produced 2 printed circuit boards to choose between a 6 and a 12 lead ECG. On the first printed circuit, there are the main components to use it as a 6 lead ECG, especially for home users. The second board serves as extension to provide a 12 lead ECG for commercial use. In the figure, you can see a block diagram of our 6 lead ECG hardware. The color-filled circles represent electrodes that are connected to particular points of the body to measure the electrical activity of the heart. The difference between 2 measured values produces 1 lead. For 6 leads, only 3 ECG signals that are measured by 4 electrodes are required, because the other 3 can be calculated using software. As can be seen in the diagram, there is 1 electrode, the black one, which is not directly used for measuring. This one belongs to the right feed drive circuit, which ensures that the circuit works at the same potential as the hardware, as the body. By the way, 10 electrodes are used for the 12 lead ECG. Let me now explain how a hardware channel is designed to produce 1 lead. As an ECG is often indicated while defibrillation, diodes are used for overvoltage protection. Before the difference between 2 measured values can be amplified by a differential instrumentation amplifier 10 times. A high-pass filter is used for eliminating a steady voltage of the body and limiting the bandwidth. It has a cutoff frequency of 0.15 Hz. The Bessel low-pass filter 4th order is responsible for anti-aliasing and removing interfering signals above 30 Hz. Instead of the Bessel filter, we also tried to use an inverse Chebyshev filter 6th order, but because it has a faster roll-off. But unfortunately, it deformed our hard curves due to its high group delay and its bad impulse behavior. After filtering the signal, it is amplified again by a factor 47 before our microcontroller is responsible for the further procedure. The microcontroller samples the lead data 500 times per second and makes an analog digital conversion to convert the analog measured values to digital ones. Since it has a resolution of 10-bit, the analog signal can assume 1024 digital values. Afterwards, a digital FIR filter attenuates 50 Hz interfering signals by 90 decibel. Finally, the microcontroller transmits the processed data to the Bluetooth module via a serial UART interface. The Bluetooth module then forwards the data wireless to the mobile device.
Now it's my pleasure to talk about the special features of our ECG. The most important aspects are probably the low production costs as well as the cheap purchase price. While commercial ECG devices cost 5,000 euros upwards, our product can be bought for only 200 euros. Despite that fact, the measurements of our ECG can be compared to the measurements of a commercial product. Moreover, our device is small and therefore mobile. Accordingly, I want to point out that the dimensions of our product equate to the size of a credit card. Due to its size, the ECG can easily be transported within the pocket of an ordinary trouser. We also care about the easy operation of our Android application. As the user should not lose his or her overview of the situation in case of emergency, we try to keep the menu navigation plain and simple. At this point, I want to mention again that our product was completely developed by ourselves. All schematics, as well as the layout of the printed circuit boards and the whole Android software, were implemented by us. The last aspect I want to speak about is the open source idea. We want to provide our source code and all the other components online so that everybody has the opportunity to copy our ECG.
As we are going to present you a functional prototype, we'd like to point out the biggest challenges we faced during the year. Starting with the hardware, we spent most of our time dealing with interferences of the power grid. As we didn't have that much experience on electronic components, a lot of efforts flew into the production and measuring of new prototypes. Another issue was caused by the late implementation of a so-called step-up converter, which should power our components with the necessary 3-volt DC. Unfortunately, this step was tested too little, resulting in a bad filter quality. In addition, the first Bluetooth module used couldn't be powered stable under our circumstances, so that it was impossible to achieve a decent usability. In conclusion, I want to mention that many hours were spent on gaining experience in Android programming and bug fixing.
Summing up, we can look back on 3,200 productive working hours shared among our 3 subgroups. A further impressive value are the lines of code. All in all, we wrote 4,600 lines of code using the programming languages C and Java. 1,000 lines belong to our microcontroller program, and further 3,600 were spent on programming our Android software. If you ask yourself what we have planned for the future, we already have an answer prepared for you. There are going to be tests at the emergency There are going to be tests on non-critical patients at the emergency ambulance in Ybbs, Persenburg. Detailed information about our product can be found on our website. Since we don't want to hold back our results, we have prepared a live demonstration for you.
We have already connected Gerald with the ECG. Now the Bluetooth module sends the measured values wireless via Bluetooth to our Android tablet. On the Android tablet executes our own app. And this Android application displays the hard curves on its screen. You will see in a few moments. Now you can see the hard curves. And as we use an Android device, we are able to provide additional features. So the users are able to record the ECG. The recorded ECG can be saved or printed directly via a network printer. Furthermore, the recorded ECG can be also sent via email to a doctor who is able to analyze the ECG. We also implemented an emergency call function. This function allows people who are in a critical condition to make an emergency call. The number which should be dialed can be of course configured in the application settings. As you can see, in our case, my phone will ring. Should the patient's heart stop beating, someone immediately has to reanimate the patient to save his or her life. As only a few people are able to do a reanimation correctly, we implemented a reanimation guide. During the reanimation, an audio file gives the first aider clear instructions what to do.
Die Person muss mit freiem Oberkörper am Rücken auf einer harten Unterlage liegen. Brustkorb, SV-Gürtel, freier Nacken und Fluchtpunkt aussuchen. Handballen in der Mitte des Brustkorbes liegen, mit gestreckten Armen senkrecht das Brustbein 5 bis 6 cm eindrücken, 30 Mal wiederholen.
Now we're at the end of our presentation and we thank you for your attention. Wir stehen jetzt natürlich noch gerne für Fragen zur Verfügung. Wir können gerne uns nochmal die Hardware genauer anschauen. Wir haben auch einige Exemplare dort zum Durchgehen vielleicht.
Fragen sind natürlich auch in deutscher Sprache zu stellen. Englisch ist keine Pflicht. Bedankst du dich?
Ich möchte an dieser Stelle vielleicht noch einmal erwähnen, diese Gruppe hat auch den Hospitaler Schul Innovationspreis gewonnen vor einer Woche. Und beim Wettbewerb auf der FH Salzburg sind sie noch im Rennen und da ist die Preisverleihung, glaube ich, also hoch.
Ja, genau.
Das ist ja, glaube ich, hoch. Dazu möchte ich ganz herzlich von der Schule gratulieren.
Und die Präsentation in Englisch war hervorragend. Das habe sogar ich noch verstanden.
Es gefällt uns.
Das war wirklich exzellent.
An dieser Stelle, wenn wir schon alle so schön versammelt sind, möchten wir das Ganze auch nutzen und denen Leuten danken, ohne die was das gar nicht möglich gewesen wäre. Und deswegen wollen wir unsere Professoren, den Herrn Professor Zauner und die Frau Professor Handel-Gruber, außerbitten. Wir haben da eine Kleinigkeit.
Für Sie. Bitte.
Das ist sehr nachhaltig.
Ja, damit Sie mal ein vernünftiges Haus haben.
Damit Sie mal ein Haus haben mit dichten Fenstern.
Ja, den können wir ruhig aufstecken. Machst du die App zu?